I am muted. Hi, everyone. Good morning, good afternoon, good evening, wherever you are in the world. So before we start, let me introduce you to Hadja. She's from SAP and she will be with us for the next 2 hours. So the floor is yours.
Thank you. Hi. As was just said, my name is Yatka. I'm working for SAP, the software company, and I'm working on a programming language that is called Snap. And I assume a lot of you are probably aware of Scratch. Maybe before we start, can you write in the chat where you're from, just so that I get a rough overview? Can everybody write in the chat? Yeah, perfect. So I'm currently sitting in Germany. So let me just put this in the chat, and then maybe you can tell me where you're from while I keep telling a bit about what I'm working on. So, as I said, I'm working on a programming language at a software company, and it's basically an advanced version of Scratch that we're building. So, we want to work with kids, young adults, adults who've kind of grown out of Scratch and want to learn more about different computer science concepts. And I'll share my screen for that and give you a short intro into Snap before we all start to program. Okay, this is what the Snap website looks like. If you type in snap.berkeley.edu in your browser, that's where you'll get. And this is just our website. You can see other people's projects. This is featured projects that we think are really good, like Benat, one of my colleagues and friends, curates them. Then we have an annual conference. So those are projects that people presented at the conference. And then we have a couple of topics that you can explore, like maths, simulations. They swap also. So sometimes it's games, whatever you are interested in. And you can directly dive into Snap by clicking on the Run Snap button up here or Run Snap Now down here. And this is what it looks like then. For those of you who are familiar with Scratch, this should look very familiar. Let me zoom in once so you can actually see more. Let me refresh. So on the left-hand side, you see blocks. This is how you program in Snap. And I don't know whether you have any programming experience, but if not, you'll get it today. So on the left-hand side, as I said, this is what we call the palette, and this is where you can do things. So this is where you find all the commands, all the functions that you have, and you can run all of them directly here in the palette. So for example, if I click on the Move 10 Steps block, you see that whenever I click, that this object, it's called the sprite that I'm programming, is moving a tiny bit. So all the blocks are live. You can click on them to see what they actually do. So now imagine you want to actually program something. It'd be very tedious to click on all of these things all the time. So it'd be much better if I could build a larger program. So imagine I wanted to animate something and I wanted to make a heartbeat. For that, I can make my object look slightly different. So the default way it looks like is this arrowy shaped structure. We call this the turtle. Why that is the case, I can tell you later if you're interested, but it's called the turtle. But you can also draw your own costumes or basically import any picture from the internet or select pictures of from our library of costumes. And you can also take pictures of yourself. And if you have a webcam, that's what we're going to do later. And now I want to draw a heart just to show you. If you want to follow along, feel free to do it, but you don't have to. This is not what the workshop is actually about. This is just a short intro into Snap. So clicking here will open our paint editor. And here you can, for example, I could draw the heart that I want to program the heartbeat with. I can also fill it, minus pink. And then if I click OK, you see that, I put it the wrong way. So let me make it point in direction and go to center again. You see that instead of this arrow thing that I was wearing before, I'm now having this heart-shaped image as an object. And I can program that. And the blocks are in different categories. So the one that I've shown you before was the motion category. So this all has to do with moving the object around on the stage. But if I want to program a heartbeat, I would, for example, want the heart to grow, like slowly grow, and then suddenly become small again, and slowly grow and suddenly become small again. So we can get this like heartbeat interaction. If I want to change the way a costume or an object looks, I can go to the looks category. And you see when I switch between categories here that the blocks in here change. So whenever I'm programming something and telling you to find blocks, I'm dragging them out from a category that has the same color. So you can identify wherever I grabbed a block from by looking at the color of the block. All the ones in the looks category are purple. All the ones in the sound category are purple too. It's a different purple, so careful. Um, so in the looks category, I can find blocks. And now I want to change the size. We have tons of blocks. So Snap is very versatile and very powerful, but it also means we have a lot of functionalities that you can choose from. A way that it's easy to find blocks is to use the block search here. So if you hover over this magnifying glass thing, you get the find blocks option. So if I'm telling you to look for a block and you can't find it right away, you can click on here. And now, for example, I want to change the size of my object. So I could type in size in here, and then I can grab the blocks I want, the change size by, and the set size to blocks. And if you want to get rid of the block search again, you can just click on any category and then it goes away. So what I want to do for my heartbeat is like slowly changing the size and then suddenly resetting it to 100%. So obviously I don't want to do that by clicking here. So I want to automatically do that. We have different kinds of blocks. Some of them have these like puzzle piece shaped structure. Those are what we call commands. And the commands block, they do something. I have other blocks where I can put stuff into. So for example, if you go to the control category, this is where you have all the control structures. And perfect. Great. So everybody can now use the chat. Great. So if you still want to type in where you're from, you can let me know. Perfect. Thanks. Um, good. Okay, anyway, I was talking about doing stuff repeatedly and having blocks that you can put stuff into. So if you scroll down in the control category, you find blocks that have this like C-shaped structure. So they look like the letter C a bit. And here, for example, we have one that says repeat. And here there's a number, and I can decide how often I want to repeat things. So, for example, I could put that change size by 10 in here, and then I'm repeating 10 times, changing the size by 10. I hope you can actually see that through the Zoom delay, but I'll just do it again. You should slowly see the size of the object grow. Okay, perfect. Now I can put these two together. So I want to like slowly change it and then suddenly reduce the size again. So whenever I do that, I'm getting this animation of a heart. If that's not slow enough, or like if this is too fast for you, you can just increase the repeats here and then maybe just do it 8 times. This will roughly get you to the same size and it'll be a bit slower. So now a heart always beats twice. So I'll just wrap another repeat around it. And now I could attach a block that has this wavy shape at the top, and that means that we call them start block or head blocks. And the head blocks you can attach on top of a script, and they have a trigger on them. So whenever what's written on that block happens, then the script or the program that we just wrote that's below it is triggered. So for example, I could now add the when I'm clicked block. And what happens now is if I go in full screen and I click on the object, I can trigger the heartbeat that I programmed. So this is the way you program using Snap and also using Scratch if you're familiar with that. Another thing that's quite interesting is you can have as many objects as you want, and they all have different scripting areas. So this one is now the heart that I can trigger. But here, for example, I could do something else that I could trigger with the space key, for example. Whenever I press the space key, this object is repeating 360 times, turn 1 degree. Okay, so now I'm pressing the space key, and while I'm pressing the space key and you see this is turning, I can still do the other thing. So those are parallel, it's a parallel programming language and I can do stuff in parallel. Okay, this is maybe all about how Snap works, and now we can dive in our first project. The idea is that I'll do something for you slowly, and if you want to, you can follow along. If you don't have a computer or a phone that you can program on, And I know that if you're only on your phone, it might be hard. Then you just have to wait and you just have to watch me do it and then have to wait while the others are building the project, or you can go grab a tea and then come back when I show you the next project. So this workshop is called From Media Computation to Data Science. And what we mean by that is we're using media, like for example, music, images, sounds, text, videos, anything media to learn how to code, learn how to program. Because media is a very nice way because it works with ourselves. We have large amounts of data readily available because a picture, for example, is 172,000 pixels if it's just that, like that tiny one on the stage here. So we can get easily into large amounts of data that we can learn how to work with. And the first project that I wanted to do with you we call the magic mirror, like the magic mirror in Snow White. And I'll just open a new project. And what you can do now is go to snap.berkeley.edu and then click on the run button. I'll just type it in the chat. And then you can click on there and click on the run snap button. And this should get you to the editor. Once you've opened the editor, for the first project, we want to work with a photo of ourselves. For the match, we first do it with just a still, like just a photo of us, and then afterwards, if it works on your computers, we can also try doing it with the live video. And the idea is that we use the built-in graphic effects to distort our faces, apply colors, whatever you like. If you don't have access to a webcam, you can download any picture from the internet or anything that you have on your computer, and I can show you how to do that. Okay, so your first step is to go to the Costumes tab up here in the middle, open the webcam. If you're doing this for the first time, you actually have to allow the browser to access the webcam. So this is usually a pop-up up here, and you have to allow the access of the camera. And then once you've done that, you should be able to take a photo of yourself. And then once you have the photo, you can click on cancel. And again, this is the same object that used to be this turtle sprite, this arrowhead, but it's now a photo of me. If you can't access your webcam for whatever reason, as I said, you can just go to the internet and download any picture. So for example, my favorite animal is the wombat. So I can go to Google and I can look for an image, and preferably one that's in the right dimensions. So I'll take this one maybe, and then I'll save it by saving the image to my downloads folder. And then I can just from the downloads folder drag it into, ooh, oh wait, please. Just from the downloads folder, I can drag it into my Snap window. And then I can also work with any picture that I downloaded from the internet. So here's my Bombatus ursinus. And then I could also do it with this. So again, if you can use the webcam, click on this thing here and then take a picture of you with the webcam. If you can't do that, download a picture from the internet and then just use that. Okay. Let me, yeah, and once you've done that, you can go back to the scripting area. Let me quickly grab my tea because it's in Europe, it's autumn, so I got sick yesterday and now I have to drink tea all the time. Okay, once you've got the picture, we can start experimenting with the built-in graphic effects of Snap. So go to the looks category and grab the set ghost effect to block. Again, if you can't find the block right away, just use the block search and type in effect, for example. Then you get all the blocks that have the word effect in them, and we'll grab the set ghost effect to block. And now we can experiment using those effects. The ghost effect is, you experiment with them by, is my camera off? No, okay. You experiment with the ghost effect or with the effects by selecting whichever effect you want. The default selected effect is the ghost effect, and then you can just type in a number in here. Ghost is not very interesting because it's useful, but it makes the picture transparent. So if you do ghost effect 100, then it'll just be transparent. Um, so the ghost effect makes the picture transparent. As someone's asking whether there's a French translation. I don't speak French, so I can't do anything in French. Sorry for that. But if you want, there's a in the settings menu, the first thing is language, and I'm not entirely sure whether we have all blocks available in French, but you can switch to another language and then the blocks switch. Yeah, here, for example, those are newer blocks, so they aren't available in French because those are community translations, but most of them we have. So, for example, this one is the one that we had right now is the same, the set graphic effects block. Although I have to say, I think it's easier to follow along for now if you have the same language than I have, so you can actually look for the blocks. But then once we're done and you built the whole script, then you can switch to French and see what it actually says. I think that's the easiest way. Okay, so ghost effect wasn't that interesting. Let's pick another one. The color effect, for example, if I set that to 50, and let's actually do it with my face again. And you see the effects stay when I switch to a different costume. You see that my kind of pale red face now got turned blue. Unfortunately, I'm only wearing black stuff, but the behind me, the flowers, they used to be yellow and red too, so they're kind of blue now. And I can pick another value here, 30, for example, makes my face green and the stuff behind me green. When I type in 70 in here, I'm getting blue. When I'm typing 100 in here, I'm getting the original photo back. So everything in the color effect is on a scale from 0 to 100. And after 100, it just doesn't. You need to click on the block to actually change it. So clicking on the block executes the script. And then you can try other effects. So for example, the saturation effect that changes the saturation. So as you can see, my face actually, like the basic color of my face is red, the basic hue, because if I up the saturation, I'm just terribly red. If you take the saturation out, for example, -50, then everything gets kind of grayish. So that's what the saturation does. And now just take 2 minutes and then experiment with all of them. My favorite one actually is the fisheye one. Fisheye -50, like fisheye with negative values, reduces the size of the center of the photo and increases the sides. If you add positive values in here, it increases the size of the center and decreases the size of the sides. So the fisheye effect is my favorite one, but just try out different ones. And we've got 2 minutes to do that. And then I'll show you the interactive version of the project. Okay, great. I see everybody's having fun with the effects. Whirl, also a very nice one. And you can also stack them. And if you want to I didn't mention that. If you're going to want to get rid of the previous effect, there's the clear graphic effects block. So the clear graphic effects resets the photo. You can obviously also reset the effect to 0, then that does the same thing. So the whirl effect, for example, is one that doesn't stop at 100. You can also do 200, then it whirls more, or 500, then it whirls more. At some point, it kind of gets hard to see the picture. Ah, good. Next idea would be to do this interactively. So the cool things about computers is you can click on this, but we can also interact with them. And one way to interact with your computer is using the keyboard, for example, but another way would be using the mouse. And mouse in this case means if you're using a touch device, the point where you touch. Okay. You can access, for example, the position of your mouse pointer from the sensing category. By the way, if you're on a touch device like a tablet or a phone, please make your object undraggable first. This is like the small checkbox here, because you can technically, don't do it, I'll show it to you, you can drag your object around. And for what we want to do now, if you can't do it with the mouse pointer, you actually want to be unable, like where you have to click to access the mouse pointer like you have to do on a touch device, you don't want to accidentally drag your object around. So just uncheck the checkbox with the draggable option, and now I can't drag my picture anymore. And what I actually wanted to say is that you can access the X and Y coordinates, for example, of your mouse pointer. 0, 0 is right on the tip of my nose on the center of the stage. If I'm very far to the left, I'm getting a large negative X value. For example, here I'm at negative 795. If I move it farther to the right, it's a less negative X value, but still negative because, again, 0 is like here. If I use Y, I can drag it up here. Now I'm at Y34. If I drag it below my nose, I'm at negative 60. So again, you have positive and negative values based on where you click on this, where your mouse pointer is. And you can use this value. So you see that those blocks have different shapes. This one, I mentioned before, is a command. It does something. This one is what we call a reporter or a function, and this block reports a value. So all the overly shaped roundish blocks, they report values. This can be numbers, this can be text, this can be other blocks, it can be whatever, but they always report something. They don't do something. But you can use this value that you're getting as an input to another block. So when I hover this over here, you see that I get this white shaped rectangular thing. And if I release the block now, it goes in there. So for example, now I could set the pixelate effect to my mouse. That's actually not very interesting. Let's do the color effect to my mouse Y position. And if I do it here, it's blue. If I'm moving it further up, it's green. If I'm moving it further down, it's a different color. So again, this is based on the position now. But this doesn't really make a difference from just typing in different values in here. So we want to automate that. And again, I already showed you for the heartbeat thing how you can repeat things, but that was with a specific number. You can also just do things forever. This is an indefinite loop, and you can wrap this around. For example, I've now got the set color effect to mouse Y, and if you activate it, and by the way, you can always see whether a script is activated by like looking at the halo thing around it. When it has this green halo, it means it's active. There's also a red halo, that means there's something going wrong, so that's not that good. And if it's off, it doesn't have that halo thing. So now when I move my mouse around up and down, I'm changing the color effect of my object. If I'm moving left and right in an actual straight line, it shouldn't change. But we also do have the mouse X value, so I could pick another set color effect block. As a set effect block, I already have the color, so I want a different one. So for example, as I said, whirl is quite nice. And now I can use my X and Y position to use the whirl effect. And I can use the up and down to set the color effect. And you can stack them. Like if you want another one, so for example, with the color, I also want to do the fisheye effect because I like it so much. You can use the same value for several effects. So this is also supposed to be, no, sorry, the Y. So now up and down does fisheye and color, and left and right does the whirl effect. Okay, 2 minutes for everybody to build this. Let's do 1 minute for everybody to build this and play around with it. I see there's a question in the chat whether we can get the recordings of the webinar. I'm not even entirely sure. I know this is recorded, so maybe someone from the team can chime in and tell people because I don't know actually how and whether you'll get the recordings. Thanks. Okay, I hope this works for everyone. If not, let me know, then we can try to fix it. But otherwise, I think we're good with this one. And now we can kind of try to use the live webcam to do a similar thing. Because I said this project, I call it the magic mirror, but this is not a mirror. This is just a still photograph of myself. For a mirror, I actually want to mirror what I'm doing in the camera and still do it with the graphic effects. So to do this, I'm stopping the script. I'm resetting it, setting it. Come on. Okay, perfect. And I'll just hide this object because I want to work in the same project. If you want to make a new project, that's fine too. But I'm hiding this object so I can just make a new one that I can see. In the looks category, you can find a hide block. And now you can hide this object. It's hidden. To show it again afterwards, I'll also drag out the show block, and then this shows it, this hides it. By the way, I can save my project, and I'll just call this Magic Mirror JOTA, and then I can share the project for you. But so if yours doesn't work, you can now, so this is the version to my, like this is the link to my version of the project. And I'll keep this around. So if you want to open it at some other time, you can use this one. And you can also just upload a photo of you to that then. So that works too. Okay, to do the actual mirror thing with the live video, we need to create another object. We have different ways to do that. I usually recommend as a workflow, we'll just make a new turtle sprite and then we draw a mirror costume for it. So again, you go to costumes and you draw something this time. So instead of taking a picture with the webcam, we want to draw a mirror. And my mirror is going to be like a filled out, make it filled, but a filled ellipse. If you rather want a square or a rectangle, that works too. And then I'm just doing this. This is my mirror, and this is what it looks like. And then you can drag it somewhere in the middle. Good. If you have that, once you've had that, the first thing we have to do is to actually create the mirror impression. And we do that by turning on the webcam on the stage. So we have the possibility to show everything that's happening in the webcam just as a video feed on the stage. And you can do this by using the video capture block from the sensing category. It's right the last one right at the bottom. And to turn the video capture on, you once have to click on this. This is like a toggle. And whenever you click it, it switches from on to off, or from true to false. And then once you have that, you can turn on the webcam. Hi, if you just joined right now, we're currently working on the Magic Mirror project. The idea of this workshop is to learn programming by using media. And if you want, you can dive right into it with my link to the project. I'll post it again. This is my version of the project. I just saved it right. Wait. I just saved it right now. If you click on it now, you should have my version of the project. We're working in Sprite 2. I can also name this mirror. And you need to click on video capture to on once to actually set the video capture to on. Okay. Now I want to display the video capture on this mirror that I made. How can I do that? I need two blocks, and one of them is from the sensing category, so I'll grab this right away. It's the video motion on myself block, and this block has different options. I didn't tell you about this before, but some blocks have what we call input slots or parameters, is what you call it in computer science. And a parameter can, for example, be something like the numbers we used before, or it can also be read-only parameters where you can only choose from a specific list of parameters. That was, for example, the graphic effects that we picked on before. And here we have different parameters that have to do with the video. One of them is whether I have motion on my video. So this is like how much motion is on the video, then which direction is the motion coming from, and one is actually the video snap on myself. And myself in this case means the object that's asking, so the mirror. And if I click on this block, instead of getting a number, I'm getting the cut out, overly shaped, mirror shaped version of the webcam. So I'm getting the part of the webcam that's currently behind the object. So for example, if I'm moving like directly in here, I should get my whole face in here now. If I'm moving half out, I'm only getting half my face. So this is always what's currently behind the webcam. And the next step is we want to switch to that as a costume. So we want to not only have it in a picture in here, but we actually want it on the mirror. And we can do that by using the switch to costume block from the looks category. And I can drag this in here. So here you can select all the objects that you have, or you can just drop an image file in here or an image in here. And luckily we have this image. So when you click on this, several times, you kind of get like a video on it. So this is just, again, it's like if you do a stop motion video, this is just a like subsequent stills. Whenever I'm clicking on it, I'm getting a still photo. But if I'm clicking very fast, it looks kind of like a video. And again, we can do this all the time using the forever loop. And then I'm actually getting kind of the impression of a video. One last step, because I'm still seeing the actual webcam on the stage, and I don't want that. So you can put all of this together. And then you can set the transparency of the webcam to 100. And if you do that, only the part that's visible on the photo or on the object is not transparent, and the rest of the stage is transparent. And then you can put all of it together and click on it again, and then you should have your live video on the mirror object. Okay, everybody, please do that if you're participating and following along. Like 1 minute to do that. Okay, great. Seems to work, at least for a couple of you. And now we can do the same that we did before by just using the graphic effects again. In this case, I want to control it maybe with the keyboard, so I can create different mirrors in my mirror cabinet. And I'm doing this whenever a key is pressed. Again, if you're on a touch device, you can't really use the keyboard. Then you can maybe do the when I'm clicked or something, then you can press on the object, or you could do something like when and then have a condition in here, or you can always just click on the script that you've programmed. That works too. So for example, in this case, maybe with the space key, I want to reset the graphic effects that I have. But with the plus key, for example, I want to change. In this case, we can use the change by, because whenever we click the plus key, we want to change it. So we want to add to the current effect that we have. And for example, when I press the plus key, I want to change the fisheye effect by 5. Now I'm clicking plus, 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 and then I can do the same thing that I did before with my live video and it works. And now I can copy this and duplicate it and can set when I do minus key, then I'm changing the fisheye effect by -5. So I'm pressing space and now I'm pressing the minus key and now I'm getting the negative fisheye effect and it still works with the live video. And then you can like, let's do 5 more minutes to 3 more minutes to explore other effects because you can again stack them all together. So for example, when we do C, we'll change the color effect by 5. Yeah, so we're right. The question is the mirror controllable? Yeah, so we programmed this mirror. It's not an actual mirror. We programmed it by constantly adding these still photos on the object that we have. So again, if you missed the beginning of this, we made a sprite and we added this empty like black oval as a costume for the object. And now we're telling the camera to constantly put that part of the camera that's on the object as a costume for the object. So now this is how we create the impression of a video by constantly putting a new snapshot on as a costume. And then we can apply graphic effects to that object. And now I have space clears the graphic effect. So again, this is just the basic version. C changes the color now. Plus changes the fisheye effect. And you can do different ones of them, like you could do W for the whirl effect or whatever you want. And again, if you don't have a keyboard, instead of pressing keys, you can also just clicking on this. This does the same thing. And then, yeah, maybe again, we do a bit of experimenting time, but you, for example, you can duplicate this whole thing and then you can make it transparent. And you could, for example, just blur it a bit by moving them kind of close together. And if you have the video on both of them and you make them half transparent, so I'm setting the ghost effect to 50 in this one, and I'm setting the ghost effect to 50 in this one. I'm kind of getting a blurry version because I'm moving I'm just doing the same thing slightly off. Or you could do something like you can turn this around. Like for this one, you can point in direction down. Oh no, wait, left. And now I'm having I go to the center with this one. So now I'm having two versions of this thing on top of each other. And I can mirror the mirror. So there's other things that you can explore too. Okay, 2 minutes for everyone. This one kind of looks nice with the hands. Hmm. Okay. Again, I'm saving my version. I'm adding two more head blocks. So we start this with the green flag and we start this with the green flag. So if you open the project, if you open my project now, you can, and let's do this too. And let's do this too. If you open my version of the project, because graphic effects aren't saved and the camera isn't on by default, you can click the green flag and then it'll show. And I still have this other object in there. So if you want to go back to the still, you can just show this again and hide the other two then obviously because they're in the way. But this one still works. So it's all in the project. Good. Okay, so this was the first activity, and as I said, this is a kind of a nice introductory activity, but we already learned about how to do stuff repetitively. We learned that there are blocks that report values, or like parts of a program that report values, parts of a program that do things, and okay. Somebody's asking, could you use this to control objects like a drone or moving a robotic arm? Huh. I mean, not with the default Snap. There are versions of Snap for Arduino, for example, that you can access as a library from here. Um, that not for everyone, just for the person who asked the question. S4, this is the S4A connector. And here, for example, you can work with Arduinos, and Arduinos are kind of microcontrollers that you can program. We also do, one of my colleagues, he actually works on an awesome programming language. It's called Microblocks. And Microblocks is a programming language for microcontrollers that kind of works similarly to Snap. And it's also live and parallel and everything. And this is meant for robots, for drones, for stuff like that. So physical computing. So if you want, I'll put the link in the chat. You can check this out. It's again also a free and open source programming language. Just try it out. It runs in the browser too. You obviously need the right hardware to program it. Okay, so I'll close this project now. I saved it to my account. Again, at the end, maybe I'll just work on a different thing. I can post all links again of all the projects that we built today. The next one also works with the webcam, but it's like a more artsy approach to working with our photographs because we want to create a pointillistic impression of ourselves. So pointillism is an art form that like happened after Impressionism, and as you can see and hear in all the photos, the images are created by drawing differently colored dots. Like here, for example, you can see that we have this like rocky structure that's all red and orange dots. The water is all blue and pink dots. The tree is all green dots. And we can do this with a photo of ourselves. So again, you already know how to take a picture of yourselves. That's of ourselves. Oh no, wait. Well, let's start with just confetti because we want to understand how colors work now for this project because we want to draw different colors and we use the pen and snap. So first we start with an object and we just draw dots. So to draw a dot, we put the pen down, we put the pen up, and in the middle we move 0 steps. So if you do this, you're getting a dot, but it's teeny tiny. Mine is like here. It's this thing that looks like dirt on your screen, but that's my dot. So try this out, move your object somewhere, click on the script and see whether you get this tiny, tiny dot. Sorry, everyone. I hope this works for you. So to actually see whether it works, we can just increase the size of the dot. So in the pen category, you can also find a block that's called set pen size to. And if you put the pen size to something larger, 10, for example, click on it once so it's actually done. And then you click on the dot thing again, you should be able to draw larger dots. Yeah, so there's two questions. One of the questions was, what is the animal? I assume you're meaning the wombat that I just accidentally opened. Wombats are my favorite animals. They live in Australia and New Zealand, and they're incredibly cute. But we just use this as a photo for the other object or project. And the second question is this similar to Scratch? Yes, we see ourselves kind of as an advanced version of Scratch. So the idea is Snap was developed for a course at UC Berkeley. Originally, the course is called The Beauty and Joy of Computing. There's also a high school curriculum that goes along with it. And the idea is that if you already know Scratch and feel familiar with Scratch, you can go to Snap and we give you the same things, but we also have more abilities. For example, you can write, if you're into programming, you can write blocks that report values, which you can't do in Snap and Scratch. And I show you later, you can also work with lists very well with data, because this is what this workshop is about, like how we can transition into working with data. And that works better in Snap or differently in Snap. Yeah. Okay, so now we have the dots and we can draw confetti with them by moving the object to a new position and then just drawing a dot there. Okay, again, this is kind of tedious to do it manually, so we can automate this by just doing it forever. If I do it like this forever, I'm just getting kind of the same dot because I'm not moving somewhere new. So it's drawing dots on dot on dot on dot, but they're all at the same position, so you can't really see anything. But we do have a block in the motion category that's called go to random position. And if you put that in here, it first goes to a random position, and then at that random position, it draws a dot. So if you do this and start it, if you want, you can also attach the set pen size thing on top. Then it'll draw gray dots. That's not very nice confetti. It's rather sad confetti. So as a next step, I'll give you a minute to try this out. But as a next step, we can add colors to make this nicer. Okay. Then the next thing we have to look at is how you can represent colors on a computer. And as you might know, there's different color models. You might have heard from of the RGB one. That's usually how pixels work with the red, green, and blue color channels. And you can pick colors like that here too. So you have access to the RGB color system. But the problem with RGB is that it's really hard for humans to understand and pick specific colors. Because in RGB, you have these three color channels and they can have values from 0 to 255. And then you always have to like calculate which value to put in which color channel to actually get a color. And then the kind of the mixture or the ratio of the channels to each other gives you the color, the hue, and then the how close a value to 255 is how bright the color is, and how low it is or close to 0 is how dark the color is. So that's kind of complicated to think about. And this is why humans invented different color systems for computers. So computers can work super well with RGB, but humans work better with, for example, HSL or HSV. And I'm quickly showing you how the HSV color model works, which is the one that we use here. You don't have to build this, I can just show it to you. Let me set the pen size to something really big, 30. And then I'm setting the hue to 0. I'm setting the brightness to 100 and the saturation to 100 because those are the three components that we have. And then when I do this, you see that I get this bright red color. Let me actually also increase the size so you can see better what I'm doing. Okay, so this is the color if you do 0, 100, 100. And now we can try to figure out how they work. So to do this, I'll move a tiny bit and then I'll change the hue by 1. And I'm doing this whole thing 100 times. And then after 100, the colors repeat again. So, and then so you can actually see what I'm doing. I'm putting the pen down and afterwards I'm putting the pen up. So if I do this, you see that I start with this very bright, like very intensive red color, and I'm ending with the same very intensive red color. And in between, I have all the different hues. So, for example, yellow is something like 15-ish, then green is 20, 30-ish. This azure color is 50, then 60, 70 is blue, then I'm getting to pink, 80, 90, and then I'm getting back to red, which is 100, the same that I had at 0. What do the other components do? If I duplicate this whole thing, and I'm again starting with that same red hue, but in this case, I'm setting the saturation to 0, and I'm changing the saturation by 1, the initial color is white. So the saturation is the amount of hue, the amount of that color that I actually have in my final color. And when we start with a very low saturation, we don't have that much hue in our final color. And when we increase the saturation, we have a lot of that hue in here. So pale, not very intensive colors have a low saturation, and very intense colors have a high saturation. And then the last one is the brightness, and the brightness regulates the amount of light in your color. So if you set the brightness to 0 and change the brightness by 1, like a brightness of 0 is black because there's 0 light in the color. And then you can change the brightness and you see that you get through these like dark red Bordeaux-y colors back again to the original one that we started with. So those are the three components: hue, saturation, brightness, or hue, saturation, value in the HSV color model. And this is how you can pick any color. And you can see here, for example, it's much easier for us to pick a certain color. For example, if we wanted to have like a bright lavender color, I can check which hue that be. So this is probably something like here, hue maybe, let's say 60. And then the saturation is probably not that high, so maybe I'll do 50, but I want it very bright. And then you can see that you can easily, maybe it's even 70 because I want it to be a bit more purple, but it's kind of easy to find specific colors with these three components. So it's easier for us to understand and identify colors. Okay, now I deleted my script. I know it's here. Okay, so now we can use these three components to draw different colors. So for example, what I want you to do now is grab 3 of the set pen hue blocks and pick a different component for each of them. So the first one is the hue, the second one is the saturation, and the third one is the brightness. And if you click on this, in this case, you get this like petrol color, and then you attach this into your, or drag this into your script. Right now, it doesn't make a difference, but for later, it'd be good if you had it after the random position block. And if you click on this now, you get this new color, and while it's running, you can also tweak this in here. So for example, if I type 30 in here, I'm changing it to this more green thing. If I'm typing 100 in here, the green gets brighter. If I type 100 in here, it gets super bright. So you can do this while the project's running, while the program is running, and you can change the colors of your confetti while this works. But again, you have to actively do this. So I have to type in here. And it'd be really cool if you could automatically pick a color, a random color. And again, you remember that we just talked about these blocks that report values. And again, we have one of them that reports random values. So you can grab this pick random block from the operators category. And this block always reports a random number between the left one and the right one. So in this case, it's either 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Whenever I click on it, it's a random number. But I could, for example, set my hue here randomly to something between 0 and 99. And now I'm getting each dot has a, or let me clear this again so you can see it better. Each dot now has a different color, like a different hue. You can also grab another one of the repeat block of the pick random blocks. Say I want the saturation to be randomly between, let's say, 50 and 100. If you want it paler, say 30 to 80, whatever you like. Now I'm also getting differently saturated colors. And then you could get the same thing and say I want the brightness between 70 and 100 because I want it rather bright. And then you can again clear with the clear block and draw your randomly colored confetti. If you want to change the pen size, that works too. So if you want larger confettis, you can just have a larger pen size. Okay, now let's get back to the photo where I actually wanted to start with. This confetti thing is nice, but we actually wanted to do a pointillistic impression of ourselves. So this is good, but not what we wanted. So what we need now is a photo. Again, we can add a new turtle sprite and we can take a picture for that sprite. Again, if you don't have access to your webcam, you can download any picture of the internet and just use that. So we go to the costumes tab and take a picture of ourselves. And then since we made this object after the first one, it's like as a second object, it's not in the middle. So you can move it to the middle by once clicking on the go to X0, Y0 block. And then maybe for good measure, also make it undraggable. And then I can show you what we need to change now. You don't have to do it. I'll show it to you. I'll bring this one to the front because we can measure, like instead of picking random colors, we can find out what the color at our current position is. So we can use this pen object that we're drawing with to figure out which colors are around us in the project. So remember when we used the saturation effect on my skin that it was crazy red. So I'm assuming if I'm measuring the hue here that I'm getting something that's really close to 0 or really close to 100. So let's try this with the, and you can drag this one out too, hue at myself block. Myself being the object that's asking, so the sprite that we're drawing with. And if I click on this now, I'm getting 98.6, which is pretty close to 100 and was what I expected. I can try another component with my black t-shirt. So I'm assuming that the black t-shirt has a rather low brightness. If I click on this here, I'm getting a brightness of 4. So that's also what I assumed. And then maybe let's try the saturation. So I'm sitting in front of a white wall, but through the light, it looks slightly yellowish, but I'm still expecting the saturation to be rather low. So I'll click on this here, and then it's 3.4. So this is a very low saturation. And we can use this value, and so instead of drawing random colors, we can use these values as an input here. If you don't want to lose the confetti, you can just duplicate the whole thing, put it here, then you still have the confetti. I can even add a comment. This draws randomly colored confetti. And here I throw the random ones out. And instead of the random ones, I'm adding those. make sure that you set the right component to the right value. So I want to set the saturation to the saturation at myself. I want to set the brightness to the brightness at myself, and I want to set the hue to the hue at myself. And if I do this now, and I'll do it slowly so you can actually see, the object is going to a no, even slower, sorry. The object is going to a, let's start this again. Okay. The object is going to a random position now. Then it's measuring the hue at that position, 9.6. It's setting the pen size to that hue. It's measuring the saturation at that position, 21.2. It's setting the saturation to that. And now it's measuring the brightness. And now I'm having that color that was at the tip. And then there I'm drawing the dot. So now it's moving to a new position. And I'm clicking through this and you see how it adjusts the color and then draws the dot. Obviously, you can't see the dot yet because I'm in the way, like my picture is in the way, but you see wherever it goes, it adjusts the color, then draws the dot, and then goes to the new position. So let me make this faster again. Let me run this. And now as a last step for this project, you need to make the picture transparent again. We already know about graphic effects. We know how to do this. So additionally to going to the center, we also want to make the photo transparent by setting the ghost effect to 100. And again, for good measure, let's add the green flag. So when we click the green flag now, we're getting half confetti, half my face. So let me clear again. And now you see that it's always doing it in the color of my face. This is rather slow. If your computer is faster than this, you can access what we call the turbo mode. So the turbo mode makes the project just run as fast as possible, and how fast that actually is depends on your computer. So if I access the turbo mode on mine by shift clicking the green flag, you see that mine gets super fast, but I have a pretty good computer, so on yours it might be slower. And you can now try different things. So for example, if you change the size to something bigger, you can see it less well. If you change the size to something smaller, just 5 and clear again. Although there it probably might be better to not run it with turbo mode. You see that it's you're getting interesting intermediary steps. So where you still can see the white thing. So there's fun stuff that you can do. Another thing is you can, instead of drawing dots, you can also draw lines. So I'm setting the pen size to 1 and I'm moving 10 steps and then I'm getting lines. If I do it like this, you should be able to see it. You can let these lines face in a random direction. So I can point, I could point towards the mouse pointer. Then I can keep my mouse pointer here. Oh, wait, I first need to go to the random position. And then I'm pointing with the mouse pointer so I can move the orientation of the lines. Or you could point in a random position. Then you're getting like a, it looks a bit like you're sitting behind a frozen window. You can select a fixed hue. So now have the hue 50. You can also take out the saturation. So now it's just 2 colors kind of. Or you can shift colors by not just setting one fixed color, but rather whichever color you're having, you're just adding 30, for example. And then you're getting the colors you had before, but shifted by 30. So not everything is in one color, but you can shift the ones that you had. So there's fun things that you can do. Maybe you'll get 2 minutes to explore that. And while you do that, I'll save the project and share the link with you again. Okay. Ah, another interesting thing, sorry, is there's another color component that I didn't mention before. It's the pen transparency. So you can also set the so when you use the RGB color model, there's RGB and A stands for alpha, which is kind of the transparency of a pixel or of a color. And if you use the HSB, HSV, HSL color models, you have this component that's called transparency, and that's the same thing. This is how transparent a color is. And if you do the same thing, so let's maybe go back to dots again. Um, if you're doing dots, but you do them with a very high transparency, that kind of looks nice too. So I'm setting the pen transparency to 90 now. And if I do this, you see that I'm like, if you run it forever, it just gets a blurry image. But if you do it, if you clear and just run it for a bit and then pause, you're getting this kind of. And my mom used to do silk painting, and I think that looked a bit similar. It's kind of nice. This looks better if you do it with landscape images, but kind of cute. So the also explore the transparency if you're interested. One of you asked in the Q&A that I didn't have open, sorry, how you can clear the stage again. So there's the first block in the pen category is called clear. So what I usually find very helpful is, especially if you're doing stuff with drawing, if you just build a reset script. And in my reset script, I usually do something like when the space key is pressed, go back to the center and then clear the stage. And then if you press the space key or click on this one, you'll get a reset of the stage. And for everybody who's asking for the challenge code, I don't even have it, so you'll have to wait until the end of the session until somebody gives it to you. Okay, let's maybe give everybody 2 more minutes to try this out. And also, if you're interested, you can, if you want to export this as a picture, for example, you can right-click the stage and select pick, and this gets you a PNG picture of the stage. It's not super high res because the stage is 480 by 540 pixels, but no, 480 by 360 pixels. And but still, it kind of works. What you can see here, though, is you also see like this is a picture of everything that's shown on the stage. Also, I look a bit creepy on this one with the pink eyes. Anyway, it's also we also have this turtle sprite in here. That's the pen, the drawing sprite that we have, but you can just hide this. If you want to take the picture without this, you can just hide the object and then create the picture, and then you're getting the same thing with out the sprite. And it can also draw like this. I mean, sometimes it's useful to actually see the thing so you know where it is and what you're doing, but it can also draw while it's invisible. That's no problem. Okay. There's also a very nice version of this, but maybe nah, anyway, maybe we'll just do photo computation because I actually also wanted to switch to sound, but it's kind of nice. You can do and we can do it in the same project. It's really cool. You can do the same thing in a grid. So here we're going to a random position, and this takes quite a lot of time. But instead of doing it randomly, you can also load a library with additional blocks, the tiles library, and that just moves over the stage in a grid, and that makes it much quicker and easier. So what you can do with that, let's just build it together. So to load the blocks, you can click on the on the file menu up here, and go to libraries. And in there, you can type tiles. And then you get to the tiles library, or if you don't want to write it, you can scroll down to the tiles library. It's pretty much at the bottom of this very long block that starts with mobile device sensors, where you can access the tilt sensors of your phones and tablets. And it's here at the back, and you can see at the end of this, and you can see that, oh, sorry, tiles. This gets you three kind of loop structured blocks that all have the name tiles in there, and you can just load them. So by clicking import, you load these additional blocks and you find them in the category of the color they had. So here, for example, we now find the tiles block, and we can either use this one. This one lets us specify the amounts of columns or rows we want, or this one, this specifies the size of the tiles. They kind of do the same. So if you want to do this, you can just use this whole thing if you're interested. You can just duplicate this whole thing, starting from the hue at myself, and duplicate this in here. And now you should be getting, wait, let's do pen down and pen up, and let's clear. You should get, let me reset the transparency. 0. So what you're getting here is now the same thing that you had before, but in a grid. Like a raster graphic. And now we can use a technique that's called dithering. And this is how we original images for newspapers were made back in the days when you could only print black. Like nowadays, you can print grayscale and you can print colors, and that's all no problem. But with the first printers, you could only do black. And still, you could kind of get the impression of a grayscale with the technique that I just mentioned that's called dithering. And the idea is that instead of measuring all these components, we're only measuring the brightness. So we're just using one color, and you can pick one, like any that you like. You can pick, for example, I want mine in dark blue. So I'll pick one color, and now let's do it first with just the dots. And let's maybe adjust the size for the dots so that they nearly fill it out. So no, 15, let's do 15. So this, for example, would be the grid. But what I want to do now is I want to use the brightness as a measurement for the size of the dots. So where it's bright, I want to have smaller dots, and where it's dark, I want to have larger dots. And we can we can use this idea and just set the pen size based on the brightness. The problem is if I use it like exactly this, I'm getting values from 0 to 100. So if I do this, I'm getting dot sized 100 at some point, which is super big. So we don't want to do this. Instead, we want to divide the brightness by 10, for example. Oops, by 10. And use this as an input to the pen size. So if I drag this in here, this is kind of my script now. I'm setting a color. Then I'm going over this with tile size 20. And in the center of each tile, I'm measuring the brightness, dividing the value by 10, and I'm setting the pen size to this. And if I click on that, wait, let me clear again first. If I click on that, you see that I'm kind of getting, this is my t-shirt, this is my hair, this is my glasses with the reflection of the computer. We can make the tiles smaller. So for example, do the same thing with tile size 10. There we can see it much better. Again, this is my t-shirt, this is my hair, maybe even we do size 8. The problem here is that I'm doing a negative. So everything that used to be bright is dark now, like the wall behind me, and everything that's dark, like my t-shirt, my hair, is bright now. So that's reverse. What we can do here now is we can have a maximum size. So take this out again, and we can have a maximum size for a dot, maybe 10. And then we're just subtracting the value from that. And now if we do this, I'm actually getting a positive of my thing. Maybe we'll use 8 here. Nah, maybe I like 10 more. Okay. And the nice thing is if you do this smaller, you actually get this kind of grayscale impression that I was talking about. If you increase the amounts of dots here by making this smaller and making this smaller, you're kind of getting these grayscale, blue scale images. And again, I'm just using this one color. I'm just using this one very blue color, but still I'm getting the impression of grayscale or blue scale by just using differently sized dots. And that used to be the technique that they made original newspaper photos with. And it's quite nice. And also, this again works with the live video. So I still have this script from here. Let me actually export it. I'll send you the script later. And let me import it here again. Because the nice thing is this also works with the live video. So I can turn the webcam on again.
Mm.
And now, as you can see down here, it's transparent, so the ghost effect is on 100. But if you look closely at the object here, I'm switching to a new costume every time. So now if I click here, each time I'm getting a new version of my dithered picture. And I can also not just click every time. I can again do this automatically with the forever loop. And if you do this, and clear in the middle every time. This one you can actually put outside. You can do this whole dithering thing with the live image again, and this works while I'm moving. It's pretty nice because we don't have that many dots, so it's kind of fast. I mean, this is like, I don't know, 172,000 divided by 5 or so. It's not that many. It's pretty quick for a computer to do this. Um, and it works with the live image. I can change the color of this. If I rather wanted pink, I can just start it again. Now it's pink. I want it in yellow. It works too, although you can't really see it that well. So this is kind of nice. And again, this is like a historic thing because this technique was used for a very long time. And we talked about colors now. So what I want you to, I don't like the yellow one. What I want you to take out of this is you can represent colors differently on a computer. And one way to do it is using the HSV color model. So you have different components, hue, saturation, and the brightness, the value. And you can build any color from that. And you can measure these values from an environment. And you can make nice things with them. And you can do stuff in grids. So maybe this is the nice thing about this project. Let me add a green flag here again so we can start all of this with the green flag. And if you open the link now that I sent before, this should contain the project. And if you click on the green flag, it should work with your webcam and your link. Yeah, webcam and your photo. Okay. Good. Okay, so this was the third project that I wanted to do with you, and we've kind of now explored a lot about images. So I'd go on to the next thing in media. As I mentioned, you can also access the microphone on your computer. So let me actually stop this and open a new project. No, I'll open it here so I can share the links with you afterwards. Because you can also access the microphones, and this is the first time that we're actually working with larger amounts of data. And you can access the microphone again with blocks from the sensing category. Um, there's one question in the chat which is about whether there's access to these materials. So I can send you the link right now. And we do have an online course that contains most of these things. It's called From Media Computation to Data Science. It's hosted on the learning, what? Media computation, learning site of the company I'm working for. You have to sign up, but the course is for free and the website is for free too. And all of the projects I've showed you today are in this course. So if you're interested in more of these things, you can absolutely go there and try it out. There's more projects. And this is video lectures and then a PDF that goes along with it and projects. And again, once we're done, stay around for 2 minutes and I'll send you all the projects that we did today. If you wait until tomorrow, I can even add comments. Then maybe it's easier to follow what we did today. So now we're switching to the audio part. And for the audio part, at first, often I think it's really helpful to analyze information first. And we can access information from our microphone with the microphone block. So I'll just type microphone in here. And then I can grab this block, and this is different options of stuff from the microphone that I can access. The first one is actually the volume. So yeah, I want Chrome to allow this. Yes, allow. I got a new computer, so I have to now first allow everything for the first time. So I'm clicking on this now, and while I'm talking, you see that the values change, and now I can talk very loud, and then the values are a bit larger. If you actually yell at it, you can get up to 60. If I'm very quiet, the values are rather low. So I'm clicking about 1.2. So you can see this is, for example, the volume of the microphone. There's a frequency. So for example, each note kind of has a specific frequency that's attached to it. So for example, if I sing in here, this is a frequency of about 1200 hertz, apparently. I can look at the samples of the microphone, and now we're getting into the data thing. So, for example, here you see that I have a list of 512 elements, and all of these are tiny values, 0.005. Some of them are negative, 0.01. Some of them are positive. I have 512 of them, and we can now try to plot them to understand a bit more about sounds. And by plotting, I mean we take our object to the left side of the stage, and then we'll just plot it on the stage. So we go over the stage, and at every position we draw the y like value. The value that we're having here will plot as the y value while we're moving across the x-axis. So we're basically getting a plot of this information. So let's start together by moving the object to where it should be at the left of the stage. Let's keep y at 0, and let's move it to x minus 240 because that's the left of the stage. So what you can see here now, this tiny thing is the tip of the object. So it's now at the left side of the stage. If you wanted to do it and change the size of the stage, there's actually also a way to access just the left of the stage here. So you could also do this left of stage, and then you could do it for any sized stage because you can change the size of the stage. But let's just go to x minus 240. Sorry, I'll be back in a second. Okay. So now we're at the left of the stage, and what we want to do now is do something for each element of our data here. There's a block that's called for each, and it's a loop too, so it's a repeat block. But the nice thing about this one, and this is why you can find it in the red category, it does stuff for each item of a list. So I have this list of 512 samples, and I can just put this in here, and I'm now enumerating, is what it's called. I'm enumerating over the list, and every time, so the first time I'm doing this, I'm getting this first 0 in here, and it's stored in this item thing, and then I can do whatever I want. And then it's going to the next one. Next time I'm getting the second 0 here. So let's actually do something here. So now the first time I'd get the 0, 0, 0.02, then I get the 0.04, then I get the 0.05, and they're all stored in this item thing and I can do stuff with them. And what I want to do now is for each of them, I want to go to a new position. So I want to go to the X position plus a step that I have to calculate, and the Y position is supposed to be the item for now. So first, sorry, I forgot that. We need to calculate how many, like how far each point needs to be apart. And we can do that by dividing the resolution of the microphone. So these 512, no, so dividing the width of the stage by the resolution of the microphone. So let's do this. We'll calculate the step. And let's just add a variable for that, step. And the step is, as I said, the width of the stage divided by the microphone resolution. And I can just type 480 divided by 512 in here because I know it. Or you can actually grab the values and then it works with different resolutions too. You can do the width of the stage divided by the resolution of the microphone. And then you see that the step, oh no, you can't see it. The step is 0.93. So between each new point, we need to like change X by 0.93. And we can do that by just going to the X that we were right now. X position that we are at right now, plus the step that we just calculated. Okay. If I run this, you'll see that it, oh wait, sorry, we need to put the pen down too. And then we need to put the pen up once we're done, or we can just put the pen down here. So if I do it like this, it'll take forever and it'll very slowly draw the line while I'm talking. So I want this in an instant. And as you remember, I can do this by just putting the turning the turbo mode on, shift clicking here, or you can wrap a block that's called warp around it. So the warp block does everything that's inside of it at warp speed, which is super as fast as your computer allows it. So I can put all of these things in here, pen up 2, and now I'm getting it in an instant. There it is, getting it in an instant. Okay, what we can also see is, although I'm getting this in an instant, there's not really anything happening. Why is that? When we look at the samples again, we see that they are tiny values. So I'm setting the Y position to something that's minus 0.1 here to, I don't know, maybe 0.3. So we're getting kind of a thick line because we have these tiny spikes, but the values are just too small. So what we should do is multiply this with a factor that we have. We can multiply this times 100, for example. And then if I'm doing this and clicking again, clicking again, clicking again, clicking again, clicking again, so you can see that each time I'm talking while I'm doing this, I'm getting different samples. Okay, maybe do it this far and try it out a couple of times. The problem is to turn off your mics because you kind of have to talk while you do it. Otherwise, you won't be able to, or you just have to make the speakers very loud so you can hear me talk while you do it. Just click on it a couple of times and see whether something changes. While you do that, I'll talk, so you can use the microphone, the speaker, and I'll save the project again. So I usually call this the oscilloscope project. So this is JOTA. I'm saving this, and I'm sharing this. Yes. Okay, and then again, I'll post this in here. And once we're done, in this link, you can also find the final version of the project. Because we now need to adjust it a bit. there's a couple of things that don't work well. So on the one hand side, I want to do this all the time, not only when I click. So I'll wrap a forever around it. Jip. Actually extract this because we only have to calculate this once. Okay, so now when I wrap a forever around it, it'll run and you see it'll change all the time. But now I'm just getting this very thick line and I can't really see the changes each time I'm talking. So what I also want to do is after I went back here to the left side, I want to clear the stage so that I'm only getting the current reading. So I'm adding a clear block between the pen down and the go to. And now you can see that we can actually track the samples or plot the samples of the microphone. And this is samples means kind of the signals that the microphone is getting. And what that is the amount a membrane, and this could, for example, be in a microphone, in a speaker, in our ear, how far a membrane swings to the left or right. And you can also see when I talk very like quietly that it's only like the amplitude of the things is very small. When I talk very loudly, the amplitude gets larger. So the amplitude is kind of the volume of the microphone. And then I'm sorry, I'm singing again. You can also see the pitch of sounds that people are making. And I should have brought some instruments, but I forgot. So for example, if I sing here, you see that I'm getting this kind of sine wavy structure. And now I'm trying to get from a very high to a lower pitch. What you should see, it's kind of hard. What you should see is that the frequency, so the period, the distance between these mountains and valleys is smaller when I sing with a very high pitch and is larger when I sing with a very low pitch, and that's what we call the frequency of a note. And we kind of talked about this before. So for example, when I play this sound, let me actually play a frequency. Hmm. Can you hear this through my microphone? Let me quickly, okay, so let me quickly unshare and, okay, let me stop the frequency. Let me quickly unshare the screen again and I can share with audio probably. I'm stop sharing and I'll just share this again with audio, share sound. Okay, so let's try this again. So I'm getting this frequency. So for example, here I have 440 hertz, which is a rather low frequency. I think that's an A. And if I play a higher frequency, let me stop this actually. Remember this. And I'm doing 880. So the higher the frequency gets, like the closer the mountains and valleys are together, the higher the pitch of the note is. And we can use this and explore this by using the data from the microphone. There's another thing that we can access from our microphone, and that's called the frequencies. No, it's called the spectrum, but it's actually the frequency spectrum of the microphone. um, and we can kind of use the same script that we had here before, but so I'll duplicate the whole thing. But we can look at this other thing that we have, the frequency spectrum. And if I talk and click on this again, you see that the values look different. So here I have 16, here I have 146, here I have, I don't know, 142. So those are values between 0 and 255, and they kind of represent the combination of frequencies that are in my sound. I can't really see exactly which frequencies those are, but it's a spectrum of frequencies. So we kind of need to adjust our script a bit. I don't want to multiply it with 100 anymore because I already have values between 0 and 255, so I can just use the actual item. And then the second thing is I don't want to start at the wait. So I don't want to start at the Y position 0, because if I move 255 from here, I'll just be somewhere out of the stage. So I want to move everything down a bit by just subtracting, like, wait, let's do minus 150 here. That's somewhere here. And then let's do the value minus the same 150. And now if I do this, I can plot the frequency spectrum with this kind of same script. And you see, while I'm talking, I have a lot of frequencies in my voice. So it's very, very different frequencies. And even if you sing in there and you're trying to sing like one specific frequency, sorry, I'm singing again. You see that although for us, it sounds like I'm singing one note, and I am singing one note, but this one note, while I'm making the sound, is more complex. So there are more than this one frequency that I'm singing in it. I'll do it again, and you'll look at the different spikes that I have. This is what is called the overtones. So based on and what you can hear in different instruments is kind of the different composition of overtones they have. There are instruments that have a lot of overtones that have a very rich sound, and there are instruments that have like not that many overtones. If you play this, I don't know the English word for it, but there's this like instrument thing that you can use to actually tune your instruments, and they just have like one frequency. So this is this metal thing that you can hit, and then you just have one frequency, and you can use that to tune other other instruments. But most instruments have a more complex sound, and you can use this data to plot it to understand how sounds work. So that's kind of neat. Okay, let me save this project. And then let's actually go to the last thing I wanted to do. And maybe this is more of a demo because we only have 15 minutes left. 15, 20 minutes. I'll open a new link. Because as I said, the first idea is kind of analyze data. So this is what we did now. So we now found out about different things of the microphone. And now we can we modified things. This is what we did with the images. And now as a last step, we can generate our own stuff. So let's just make, and I'm sorry, I'm apologizing in advance because this is horrible noise. Let's make our own sounds. So let me make a variable, and I'll call this, the first one I'll call noise, and I'll just make random noise. We remember the samples were values between -1 and 1. So I'll just make this noise by adding random values between -1 and 1. -1 and let's do 0.99. So I'm actually getting random values, and now I'm getting a random decimal number every time. And let's do in it, what we didn't talk about yet is how many samples I can fit in a specific time, because this is the sampling rate of a microphone or of a sound. And usually we have a play sound at hertz block. So if you play it at 44,100 hertz, a sound, that means you can fit 44,100 samples in 1 second of sound. That's what the hertz thing means. So if you want to generate 1 second of sound, we can just repeat this whole thing 44,100 times. And the stuff that I'm repeating is that I'm adding a random number to my noise. So I'm doing this. And I got these 44,000 samples here now, and I'm going to play it. Maybe careful because this is a horrible sound. So I'm playing this noise now. Careful, careful. And it's just 1 second of what we call white noise, like a full spectrum noise. Okay, that's nah. But now we said we had this component of the frequency. So we're repeating things a specific number of times. So we remember we could play this frequency, the 440 hertz. Let's actually do 441 hertz. So this is the frequency. What does that mean? In this case, this is sine waves, and I'm repeating 100 sample long sine waves 441 times in a second. And we can kind of do the same thing by, instead of using 44,100 random samples, we can just do 100 random samples. So let me make a new variable, samples. And let me just duplicate this whole thing. I'm duplicating, I'm setting the samples to an empty list, and I want to add stuff to samples, and I want to just have 100 of them. And now I want to use these samples to generate a new sound. So I'm making the variable that I'll call sound. And for the sound, I'm just adding these same samples that I have 441 times. So I'm setting the sound to an empty list, and I'm repeating 441 times. And what I'm repeating is that I'm adding each item of my samples, and you already know the for each block. So for each sample in our samples, we want to add that sample to the sound. And what we're getting now, if I do this, is another sound, and they both are 44,100 elements long. So it, on the first glance, it looks kind of similar. Those are tiny values between -1 and 1, 44,100 of them. And those are tiny values between 0, like -1 and 1, and 440,100 of them. But if we look at the first one, 0.619, and we look at the 100th one, 101, got 101. Ah, okay. We'll manage to get to the, okay, let's look at 201. That's also the 0.619. And if I look at 301st, it's also the, there it is, 0.619. So I'm repeating the same thing. And now if you listen to these both things in comparison, this, you remember, wait, let me grab the play sound. You remember this was the noise. Sorry again. This is the sound now. This was the 441 hertz with the sine wave. This is it. Was the thing that I generated from the random samples. So you can hear this is clearly the same pitch, just the timbre is different. The notes sound different, but the pitch is the same. So we can now do two things. One thing is we can change the frequency of the sound. So if I do the same thing, I'm making a new variable and I call this samples 2, and I'm making variable sound 2, and then I'm just duplicating this whole stuff because I want to do the same thing now. So samples 2 is just 50 long, and I'm adding stuff to samples 2. So now I have the same thing that I had before, but instead of 100 random values, I just have 50 random values, which means I need to repeat double the time, so 882. And I need to add the samples of samples 2, to sound 2. And what I'm getting now is a new sound that has double the frequency. So this should be a higher pitch. And by the way, doubling the pitch, like doubling the frequency means that you're 1 octave higher than you were before. So the pitch is 1 octave more than before. The pitch, like the frequencies double between octaves. So if I play this, sound 2, so I'm playing sound 2. If you remember, sound 1 was this one. Sound 2 is this one. So there's exactly 1 octave between these two. And now we can also change the timbre of things. So for example, instead of picking random values, and now I'll make let's call this samples square. I can make a square, how do you call it? Square curve. By the way, I can also plot these sounds. I can do that later for you. Let me remove this. So instead of picking random values and doing this 100 times, I'll make sample square and sound square. I'm picking 50 times the 1 and 50 times the -1, or 50 times the 0 and 50 times the 1. So I'm getting this like square wave structure. And again, I'm setting this to an empty list. And then 50 times I am adding the 1 to the square samples. And then 50 times I am adding a 0. So now if I do this, jip, I'm getting 100 samples again. So we're expecting the same pitch that we had with the 100 random values, but it should sound differently because I have 50 ones and then I have 50 zeros. And oh, sorry, I need to generate the sound again. So now I have the sound square and I'm using the sample square to sound square. Okay, so now again I have 44,100, but instead of the random values I had before that repeated themselves, I only have ones and zeros and ones and zeros and ones and zeros. And if I play this, I'm getting a totally different, it's the same pitch as it was before. So sound and my square sound now have the same pitch. It's 441 hertz. Sorry, it's 441 hertz. So I'll play this again. This was the original sound. And I'll play this again. So you can hear again, it's the same pitch, but they sound differently. The timbre is different. So what I wanted to show you with this last project, and I'll just save it and you can experiment with it. Oh wait, let me show you one more thing. You can load library and let's just do the audio computation library because we can plot sounds. So for example, when you look at I'm plotting the input to the samples that I used for the first sound. They look like this. So those are the random values. The samples we used for the second sound, the square wave, those look like this. Oh no, not the whole sound, sorry, just the samples. Those look like this. So here you can see random ones, and those are the square wave ones. And this sound is this thing here. And this sound is this thing here. Okay, so let me save this project again. I'll call this sound synthesis JOTA. Saving the project and I'm sharing the project. Okay, so what I wanted to explain with this project, like once you understood things and we analyzed how samples work, we found out that there are only values between -1 and 1. We found out that the volume has to do with the volume has to do with the amplitude. So if I'm closer to 1 or even larger than 1, I'm getting very loud values. Or very loud samples. If I'm very close to 0, it's rather silent values. And then if I'm having repetitive things, if they're very close together, it's a rather high pitch because the frequency is very low. If they're very far apart, the pitch is lower because the frequency is lower. And we could use this to generate new sounds that sounded differently with a different timbre and also that had different pitches. And the last thing that you can do with this, and now let me just open a project because I'm kind of running out of time. Audio. You can also use what? You can also use this idea. Nah. Okay, maybe we'll have to do one. You can use this idea to modify your own sound. So instead of costumes, you can also record a sound. And let me just record one. And I'll call this snap. Snap. This is my snap sound. Or I could also say something from media computation to data science. From media computation to data science. And now can access the samples of that sound again. So here I have 146,880 samples. A lot of them are zeros. This is when I didn't say anything. And then this is my sound. And I can now make audio effects. So we can, for example, do stuff like I can make the sound louder. So this is the normal sound. From media computation to data science. If I'm just multiplying all the samples by 2 and play that, I'm increasing the amplitude. We remember, so I'm increasing the amplitude of the sound if I play this. Original one, from media computation to data science. New one, from media computation to data science. So you can hear that it gets a bit louder. Also, it sounded like the pitch changed, so maybe we'll just play this at a specific rate. Just to make sure that we don't have a different, there's different sampling and playback rates sometimes, so that can be problematic. Let's try this again. From media computation to data science. From media computation to data science. Actually make this even louder. From media computation to data science. So you can see the more I'm increasing the values in the samples, the louder the sound gets. I can do other things, like for example, I can play the sound backwards by just reversing the samples. If I play them from back to front, I can reverse the samples of sound recording and then play that. Or I can, and this is kind of fun, you can make like a nasal effect by only using the absolute value. So I'm just cutting off the negative ones, or rather not cutting off, I'm using the absolute values. So all the values I have in there are positive now. And if you play this sound, so let's again listen to the original one. From media computation to data science. And then this one. From media computation to data science. So this sounds a bit like I'm holding my nose. So there's different things that once you've understood how sounds work and how you can experiment with the samples, you can do fun things. Yeah, so understanding how data works, how media works, lets you do fun activities and helps you understand the world and create funny things. And I think that's what I wanted to say to you. So I'll stop sharing now. Take a look at the chat. Okay, that seems to be all right. Let me check the Q&A thing. Okay. Still, I'm not sure whether the webinar is recorded, but I posted a link to the of the course to the chat. I'll just post all the links again. And if you wait for 2 seconds, let's rather say 2 minutes. So this was the magic mirror. And then we had the pointillism and dithering. And then we had the oscilloscope, oscilloscope. And then we had the sound synthesis. Whoop. Now that I think about it, we did get pretty far. And let me just quickly share the last, save the last one. Then you can also experiment with this a bit more if you want to. I'll just call this sound effects to JOTA and share this. There was the sound effect project. Okay. Share. This was the sound effects. And then
Hello.
finally, again, if you're interested to check out the course, this is the From Media Computation to Data Science course. You have to sign up on the website, but it's for free. And there are more videos. Also, feel free to reach out if you have any questions about Snap or want to do more things. And you can see the challenge code on the screen now. So I hope everybody's happy. And thanks for participating. I hope you had fun. I had fun, although I was mainly talking to myself.
You took the words right out of my mouth. So everybody, you have the challenge code there. And yes, a really, really big thank you. I gotta say, I was supposed to monitor the whole thing, but I also ended up playing around with everything. It was really great. So thank you so much for this webinar and all those things that we are gonna explore for the next I don't know for how long, but that's a lot of things that we can explore. So thank you so much.
Oh, thank you.
Um, and hopefully we'll see you next year for the next
Oh,
JOTA-JOTI.
you'll see me in
So
an hour for the next workshop.
also that, yes, very much looking forward to that. Thank you so much.
Bye.
And
See you
thank you,
then.
everybody.